Hello everyone and welcome back to our DSA problem solving series. In today's video, we are going to solve LeetCode problem number 215, Kth largest element in an array. This is a very important problem because it teaches us how to find an element based on its position without sorting the complete array. We will understand the problem, discuss the straightforward sorting approach, and then solve it efficiently using a min-heap. By the end of this video, you will understand first what the kth largest element actually means, second how a min-heap can maintain the largest elements of an array, third how to solve this problem without sorting the complete array, and finally how to analyze the time complexity and space complexity of this solution. Let's begin with the problem statement. We are given an array called nums and an integer k. We have to return the kth largest element present in the array. One very important point is mentioned in the question. We need the kth largest element in sorted order, not the kth distinct largest element. Let's understand using an example. Suppose this array is 3, 2, 1, 5, 6, 4 and k is equal to 2. If we arrange the array in descending order, we get 6, 5, 4, 3, 2, 1, right? And the first largest element is 6. The second largest element is 5. Therefore, our answer is 5. Now consider another array 5, 5, 4. Suppose k equal to 2. The descending order is 5, 5, 4. The second largest element is also 5. We do not remove duplicates. The question asks for the kth position in sorted order, not the kth unique value. Now let's discuss the simplest possible approach. We can sort the array in descending order and return the element present at index k minus 1. This approach is very easy to implement, but sorting the complete array will take big of n log n time, and the question specifically asks whether we can solve the problem without sorting. And yes, we can. We will use a min heap. Before solving the problem, let's quickly understand what a min heap is. A min heap is a data structure in which the smallest element is always available at the top. In Python, we can create a min heap using using the built-in heapq module. We can insert an element using heap. We can we can insert an element and we can remove the smallest element using heap pop, and we can access the smallest element using index 0. Now you may be wondering that we need to find the largest elements. So why we using a min heap? This is the main intuition behind the solution. We don't need to store every element of the array. We only need to maintain the kth largest element encountered so far. We will create a min heap whose maximum allowed size is k. Whenever we insert a new number into the heap size may become greater than k. If it happens, we will remove the smallest element from the heap. In this way, smaller and unnecessary elements will keep getting removed. After processing the complete array, the heap will contain k largest elements of the array. Among these k largest elements, the smallest one is exactly the k largest element overall. And because we are using a min heap, the smallest element will be available at the top of the heap. Now you let's understand this with an example. This is our array 3, 2, 1, 5, 6, 4 and k is equal to 2. We need to maintain a heap containing only the two largest elements encountered so far. Let's make a heap. This is our heap and it is empty right now. We will process the first number, which is 3. We insert 3 into the heap. The heap now contains the element 3. It is size is 1. Let's write the size. Size is 1 and which is not greater than k. Therefore, we do not remove anything. Now we process the second element, which is 2. We insert 2 into the heap. Now heap contains the values 3 and 2. The heap will contains the element like this, 2 and 3, because the smallest one will be available at the top. Now its size is 2, which is again which is equal to 2, which is k, and size now is equal to 2. Therefore, we keep both elements. Next, we process 1, which is the third element, and we insert into the heap. Now the heap contains three elements, 1, 2, 3, and the size is 3, which is greater than k. Now we only want to keep two elements. Therefore, we have to remove the one element from the heap, and we will remove the smallest element. The smallest element is 1. The smallest element is 1. After removing 1, the heap contains 2 and 3, right? These are the two largest elements we have encountered so far. Next, we will process 5. We will insert 5 into the heap because the fourth element is 5, and we will insert it. Now the heap containing three elements, 2, 3, 5, and the size is 3. Now we have to remove one element, and the smallest element is 2. We will remove it. Now again the size will become 2, and the heap is containing 3 and 5, and these are the two elements which is largest elements we have encountered so far. Now the next element is 6. We will insert it into the heap. Now the heap is containing 3, 5, 6. The size is 3. We will which is greater than k, and we will remove the smallest element, which is 3. We will remove it. Now the heap contains 5 and 6. We will finally process the last element, which is 4. We will insert it into the heap. The heap will contain 4, 5, 6. Now we will remove the smallest element, which is 4. Now we have completed traversing the whole array, and the heap containing two elements, which is 5 and 6. These are the two largest elements of the array. The smallest element among them is 5. Therefore, the second largest element in the complete array is 5, which is our answer. Now let's write the code. First, we will import list from the typing module. Then we will import heapq module. We will create an empty list called min-heap. Now we will iterate through every number in the array. For every number, we insert it into the heap. After inserting the number, we check whether the heap size has become greater than k or not. If the heap containing more than k elements, we will remove the smallest element. Once the loop finishes, the heap contains the k largest elements of the array. The smallest element among them is present at index 0. Therefore, therefore we will return min-heap 0th index. Let's perform another dry run using the second example. This is the array and k is equal to 4. We need to maintain a heap containing the 4 largest elements encountered so far. Now the first element we will insert it 3. Now the size will become 1. We will insert 2 into the heap. Now the size will become 2 of the heap. Now we will insert another 3. Now the heap is containing 2, 3, 3 and the size is 3. We will insert the another element which is 1. Now the size is 4. Now next element is 2. We will insert it into the heap. Now the heap size becomes 5. We will remove the smallest element which is 1. We removed. The heap is now containing the values 2, 2, 3, 3. Now we will insert next element which is 4. Now the size is become 5. Now we will insert the smallest element which is 2. Now the next element is 5. We will insert it into the heap. Now we will insert sorry. Now the size is become 5. So we will remove the smallest element which is 2. Now next element is again 5. We will insert it again. Now we will remove the smallest element. Now last element is 6. We will insert it into the heap. Now again the size is 5, so we will remove the smallest element which is 3. Now the size of the heap is 4 and we have completed the traversal of the array, and the heap is containing 4, 5, 5, 6. This is the fourth largest element of the array. The smallest element among them is 4. Therefore, fourth largest element is 4. Notice that both occurrences of 5 are included. This is the correct because the problem asks for the kth largest element, not the kth distinct largest element. Now let's analyze the complexity. First, let's run it once. Okay. Now let's analyze the complexity. Suppose the array contains n elements. We iterated through all n elements once, and the heap contains at most k elements. Inserting an element into a heap of size k takes big O of log k time. Removing the smallest element also takes big O of log k time. Therefore, the overall time complexity will be big O of n log k. And the space complexity is big O of k because we used k elements into the heap for storing purpose. This is better than sorting the complete array when k is much smaller than n. Sorting would take big of n log n time, whereas the heap solution takes big of n log k time. Now let's understand why the algorithm is correct. At every point during the iteration, our heap stores k largest element encountered so far. Whenever the heap size becomes greater than k, we will remove smallest element. That removed element cannot be among the k largest elements currently seen because at least k elements are greater than or equal to it. Therefore, removing it is safe. After processing it, uh, after processing the complete array, the heap contains the k largest elements of the entire array. The smallest of those element is kth largest element. That is exactly the value stored at the top of the min heap. Now let's discuss some important edge cases. The first edge case is when k is equal to 1. If in this case we need to find the largest element in the array and our heap will store only one element. Whenever a larger element appears, the smaller element will be removed. At the end, the heap will contain the maximum element. The second edge case is when k is equal to the length of the array. In this case, the k in this case the kth largest element of the smallest element in the array. Our heap will eventually contain every element, and the minimum element will be at the top, right? The third edge case is when we are handling with duplicate values. For example, for example, this array 5, 5, 4, and k is equal to 2. The answer is 5, not 4. We must preserve duplicate occurrences because each occurrence occupies its own position in sorted order. The fourth edge case involves negative numbers. For example, this is the array minus 3, minus 1, minus 2, and k is equal to 2. The descending order will be minus 1, minus 2, minus 3. Therefore, the second largest element will be minus 2. The heap solution works normally with negative numbers as well. Now let's look at some common mistakes that we can make. The first common mistake is removing duplicates from the array. Do not convert the array into a set. The problem does not ask for the kth distinct largest element. Duplicates must be counted. The second common mistake is creating a heap containing every element. That would use big of n extra space. The purpose of this approach is to maintain only k elements. The third common mistake is using a max heap without understanding the required operation. A max heap can also solve the problem, but we may need to remove the largest element k times. In Python, heapq directly provides a min heap. Maintaining a min heap of size k gives us a clean and efficient solution. The fourth common mistake is returning the last element of the heap. The heap is not completely sorted list. Only the smallest element is guaranteed to be the present at index 0. Therefore, we will return min heap of 0th index. Do not assume that the remaining elements are stored in sorted order. Now, let's quickly recap the complete approach. We created an empty min heap. We iterated through every number in the array. We inserted each number into the heap. Whenever the heap size becomes greater than k, we will remove its smallest element. After processing the complete array, the heap contains the k largest elements. The smallest element in the heap is the k largest element overall. We will return the element present at index 0. The final time complexity is big of n log k and the space complexity will be big of k. This solution does not sort the complete array and works correctly with duplicates, negative values and all valid values of k. That completes our solution for LeetCode problem number 215, kth largest element in an array. And try implementing this solution yourself and submit it on LeetCode. After that, try solving the same problem using quick select, which can achieve an average time of big O of n. Thank you for watching. Keep practicing, keep building your problem solving skills, and I will see you in the next video.